In this YouTube lab, we'll be learning about organic chemistry, functional groups, and combustion. Organic chemistry. We have organic compounds, which are any compound that contains carbon atoms that are covalently linked to each other or to atoms of hydrogen, oxygen, sulfur, phosphorus, or any halogen. Inorganic compounds are compounds other than organic compounds. Hydrocarbons are compounds that contain only hydrogen and carbon atoms. Carbon atoms in hydrocarbons may be bonded to each other or to atoms of hydrogen. These compounds are organized into families based on structure. Alkanes. Alkanes contain only carbon-carbon single bonds. There are two types of alkanes. One of them are straight-chained alkanes. For straight-chained alkanes, you have to count the number of carbon atoms you have, use the proper prefix, and add the ending ane to complete the name. So an example is, if you had 6 carbon atoms, then you use the prefix hex and add the ending ane to complete the name hexane. In this example, there's 1, 2, 3, 4, 5 carbon atoms, so you use the prefix pent and add the ending ane to complete the word pentane. Branched chain alkanes. You have to know what parent chain and substituents are. Parent chain is the longest continuous chain of carbon atoms in the alkene molecule. Substituents are side chains of atoms linked to the parent chain, and the ending of substantials are YL. To figure out a branched chain alkane name, you have to first figure out what your longest parent chain is. In this case, it's 1, 2, 3, 4, 5, 6. So you would use the prefix hex and add the ending ane to figure out the name is hexane. But with branched chains, you have to also figure out if there's any substituents. In this case, there's 1 and 2. And since there's one chain here, use the prefix meth and YL to complete the name. In this case, there's 1, 2. So use the name eth and add YL to complete the name ethyl. And you have to figure out which way to number the molecule. You have to go in the way which will give you the lowest numbers. So in this case, if you were to go this way, it would give you 1, 2, 3, and 4. And if you were to go this way, it would give you 1, 3, and 5. So therefore, this way would be shorter. So you would use the numbers 2 for methyl and 4 for ethyl to complete the name. And in completing the name, you have to go from alphabetical order. Since E is before M, you would write ethyl first, then methyl, and add hexane to the end of the second substituent. So another example is this, and in this, the longest parent chain is 1, 2, 3, 4, 5. So the name is pentane, and they have substituents 1 and 2, and since it occurs twice on the numbers 2 and 3, you use the prefix di to the ending of the name methyl because there's only one substituent to it. So the answer would be 2,3-dimethyl-pentane. Okay, here is another example of an alkane. At this time, could you please pause the video? Can you try to figure out this answer? And if you can't figure it out, it's at the bottom. At this time, I'll explain what it is. The parent chain of this is 1, 2, 3, 4, 5, 6. So the name is hexane. There are a couple substituents. In this case, there's 1, 2, 3. Since there's 2 substituents with the same prefix, use di, and they're at the 4th atom, so you use 4, 4. And the other substituents at 2, and it's only one carbon atom, so it's methyl. So the name for this would be 4,4-diethyl-2-methylhexane. Here's another example, and this is the answer, 3-ethyl-5-methyl-octane. Alkanes. Alkane contain carbon-carbon triple bonds. In examples of alkane, there would be 5, 1, 2, 3, 4, 5 carbon atoms, so it would be pent. And since there's a triple bond, use the ending Y and E to complete the name pentane. And to get this 2, you use the number which will give you you use the way that would give you the lowest number that will hit the triple bond. So in this case, it's 1, 2 instead of 1, 2, 3. So the name would be 2-pentane, pentine. For alkanes, it contains alkenes contain carbon-carbon double bonds. In this example, there are 1, 2, 3, 4, 5, 6, 7 carbon atoms, so you use the prefix hept. And since it's alkenes, you use the ending ene, so heptene. And then where you get the 2 and the 5 from is you've used 1, 2 to hit the first carbon double bond, and then 1, 2, 3, 4, 5 to hit the second carbon double bond. And this would give you the lowest way to name it, so it would be 2,5-heptene. These two are examples of alkenes and alkynes, so figure it out on your own, and the answers are provided for you.
Another thing in this YouTube assignment is functional groups. Functional groups are defined by characteristic arrangement of atoms. It is the part of a molecule where most of the chemical reactions take place. Also, it determines the compound's chemical and physical properties. There are 10 overall functional groups. The first one is alkene, as learned before in the video. It has the double bonds, and that's how you recognize that it's an alkene. Another one is alkynes. This is an example of alkyne where the triple bond is evident, and over here, this is how you recognize if it's a triple bond in the structure. Next one is alcohol. In alcohol, the main part to remember is OH, and then together it's carbon and then COH. This is how you remember for sure that it's a functional group. Another functional group is carboxylic acid. Carboxylic acid also has a similar structure to alcohol as in COH. However, it has a double bond to oxygen on top of carbon. And the last one is aldehyde over here. Aldehyde has 2 carbon atoms with the H at the bottom and then a double bond of an O at top. This is the main structures that you remember. These are the main structures that you remember when you try to find the functional groups in different examples given. These are the continued functional groups. Another one is amine. Amine has the basic structure. You just have to remember N in the middle. N could be involved in any of the bonding over here. As you can see, all you have to see is only N. As for amide, you have to remember the double bond of O on top and then N on the side. So it is CC, and then on the second C you have to remember the double bond of O, and then on the side you have to remember N. These both are similar and easy to remember. Next one is ketone. In ketone, all you have to remember is a single line of C's with a double bond of O on top. That is all. Next is ester. Ester is COC with a double bond of O on top in the examples. Over here, it is provided. And the last one is ether. Ether has COC. That is all you have to remember to find in a structure. Last thing in this YouTube assignment is combustion. Organics can burn. Combustible is the ability to burn. All hydrocarbons are combustible. Combustion takes place in the presence of excess oxygen. Always yields water vapor and carbon dioxide. There are 2 types of combustion. One is complete combustion and the second one is incomplete combustion. In complete combustion, the reactants would give you the product of CO2, carbon dioxide, and H2O, water. And as well as energy, since the heat is involved. In complete combustion, the products would be C solid, as in just carbon solid, and water. And for another one that would define as incomplete combustion would be this one, where the products would be CO2, but it would not be carbon dioxide. It would be carbon monoxide and water. Here are some of the more examples of combustion reactions. The first one is complete reaction, since it results in CO2 as well as H2O. These are all balanced examples, so you could try it by yourself and the answers are provided. The second one is benzene, and it is not a complete reaction. It's incomplete since it just gives you carbon monoxide and water. Third one, it isn't complete either since it just provides the reactants with carbon solid. That's all for the reactions over here. The end.
By Rujvi and Jade.
Thank you for watching.
Sure, how about